Okay, so here is a problem that is very similar to the 12.4.31. And remember, for context, they said that you've got two different automotive service stores, and for 25 days in a row, they keep track of how many oil changes they give. So it's asking you for part A of the question to construct a frequency distribution for each store. So let me clarify what they mean by that. So they gave you the intervals to use in the first column, and it's asking us to find the east store first. So that's what I'm going to do. We're using this frequency distribution for the east store. So in order to fill in this column, I need to figure out how many days the east store gave between 15 and 19 oil changes. So I'm looking for numbers that fall in between 15 and 19, and I need to count them up and put their frequency over on the right-hand side of the table. So I'm just going to go through and look for those numbers. And I know it can be really overwhelming when you have a lot of numbers like this, but take your time, make sure you're very careful about when you go through. So I've actually done that. I've gone through, and I only have one number that falls between 15 and 19. So that means that I'm going to write the number 1 next to the interval 15 and 19. A common mistake that I see a lot of people make is that they'll also count 14. Like on this homework problem, people have a tendency to write the number 2 here instead of the correct answer, number 1, because they think that 14 should go in there too because it's pretty close to 15 and 19, but it doesn't fall between 15 and 19 because 14 is smaller. You don't necessarily have to use every number in there. If they give you the interval 15 through 19, don't include numbers that are not part of that interval. So that kind of helps alleviate a bit of an issue there. So if I go through the table now, and I like to also mark them out as I use them. It makes it a little bit easier for me. So for example, I know I'm not going to use that 14 because the smallest number in my frequency table is 15. So all the numbers that I've either used or I'm not going to use, I mark them out as I go because I'm really visual and it's very easy for me to get distracted by a whole bunch of numbers. So for the next interval, I'm going to find the ones that are between 20 and 24. You'll see I found these 4 right here. So I'm going to write the number 4 next to the interval 20 to 24. Again, I'm going to mark them out so it's a little bit less distracting to me. Now I'm going to find how many numbers fell in the interval 25 to 29. You see I've found the 2 that I've just highlighted in yellow, 2 25s. So I'm going to put the number 2 here. Again, I'm going to mark those out. Now I'm looking for 30 to 34. I think you get where I'm going with this. I'm going to fill in the rest of the table. So I have just gone through and filled in all of the rest of the numbers for the frequency table for the East store. I do want to pay close attention to the fact, notice I've got this 0 right here, because if you look in the East store table, there are no numbers that fall between 55 and 59, or that fall into that interval. I really shouldn't say the word between. That fall into that interval. So you need to write a 0 there when you don't have any numbers that fall within that interval. So now what I would like you to do is maybe on your own try doing the frequency table for the West store. I suggest that you pause the video, make yourself your own table of the West store, and then restart the video and check your answer and see whether or not you did it correctly. So here was my frequency diagram for the East store. Back to the East store. Now your version is multiple choice, so I'm just going to show you how to match up the correct one. So here I have the correct histogram for, which one? Yeah, this is the East store. So I'm going to show you how you can tell that they match up. So let's just look at our interval 15 to 19. Okay, so you'll notice 15 to 19 there was 1 day. And so if you look at the interval here, 15 to 19, and you can tell that's the right one because it's the first histogram bar. The right side of it is has 20 as a boundary, so that's how you know that that's the 15 to 19. And if I zoom in here, you can see that it's exactly 1 unit high. So it matches the fact that they had 1 day that fell between the interval 15 to 19. If I look at my next interval, 20 to 24. Again, I'm going to zoom in here. So that would be the next bar. 20 to 24. You can see that it is 4 units high, which matches with the frequency of 4. I'll do one more. Let's do 40 to 44. So if I zoom in on the one that's between 40 and 44. Oops. Sorry, not a great straight line, guys. But that one right here, I can tell this is the one that's 40 to 44 because see how 40 is here on the left-hand side? And it goes up to the 6, which matches the frequency of 6. So that's how we matched up the one for the East store. The process to the East store here, I'm going to zoom in, make it a little bigger. So the center, now granted this isn't exact, but for the most part, you know, it's kind of got a shape like this. And so the center, remember this is all approximately, okay? Big keyword that they used in the question. They said, do the means appear to be about the same, okay? That implies that we're going to be estimating. So the middle of that curve is around here-ish, which means that the center appears to be right here in this 40 to 44 interval. So now let's look at the middle here is about 40 to 40. Look back here. Okay, so this is the East store. And so it's kind of spread out, right? From, you know, the 16 to rough, you know, somewhere between 16 and 70-ish, right? This one is shorter and it's a little bit more spread out. East store is more spread out, which means the East store more than likely has a larger standard deviation. It means that its scores, or its days, I guess in this case, are more spread out, which means the standard deviation is larger, in this case, for the East store. So we've just answered part D, wider and shorter, which did indicate it had a bigger standard. Okay, now part E asks you to actually, so before we estimated the mean to determine that their mean is probably about the same, now it wants us for part E to actually calculate the mean. Remember, to find the mean, you take the sum of the numbers in the data set. In other words, you add them together, and then you're going to divide them by the number of numbers in the data set. So we know that each store was tracked for 25 days. So in other words, we're going to add up all the number of days, and then we're going to divide by 25. We're going to do that for each store. And I get that can be overwhelming. There's 25 numbers in this data set, right? I mean, that's kind of a pain. I know it's really easy to make a mistake, so take your time. All right, so we're just going to go through. First of all, I'm going to add all the numbers together for the East store. I suggest that you go ahead and for the sake of following along with me, you go ahead and do the same thing as well. So go ahead and calculate the mean for the East store. We'll pause the video first and then calculate the mean for the East store, and then come back and check yourself with me in a moment. So I've just added all the numbers for the East store, and I got 925. Then I went back and I did it again. And this is where I might mention that I have a very strong recommendation. I know we've all got calculators on our phones, but for questions like this where you're dealing with a lot of numbers in a data set, I think it's a great idea to use the scientific calculator because you can always go back and it saves the history of the numbers that you put in. So it's really easy to go back and double check yourself. I'm just using my plain old phone right now, so to double check and make sure that I didn't make a mistake again, I've actually gone and I've added the numbers together twice, and both times I got 925, so I can be reasonably sure that I did that correctly. Then I'm going to divide 925 by 25, and that got me a mean for the East store of 37. Now I'm going to do the same thing for the West store. I suggest that you pause the video, go back and check yourself in a moment. And as it turns out, for the West store, I also got 925 for a sum, which means if I divide it by 25, the mean for the West store is also 25. So because the means are the same, that means that I would pick the multiple choice answer, that my answer here for part, I've lost track of what letter this is now. I think it's part E, that this is consistent with the answer I got in part C. The histograms made it look like they had about the same mean, because remember, they both had the same, they're both centered around the same number. And I just confirmed what I saw in the histogram, that the mean is the same. So for this multiple choice question, I should have picked that my findings were consistent. Now part F is asking me to do the same thing that I just did in part D, but now I need to do it with the standard deviation. Okay, now I know, so it's asking me to actually calculate the standard deviation for each East and West store. Remember back in part D, we looked at the histogram, and it appeared that because the East histogram was wider, it appears that the East store is going to have a greater standard deviation. So now we're going to calculate the standard deviation for each and see whether or not that was correct. And I know standard deviation is a lot of steps, especially when you've got 25 numbers in each data set. But guys, just take your time, okay? It's okay. Double check yourself as you're going. It's really, it's not too bad. So remember that what you need to do to find the standard deviation, you're figuring out basically how spread out the numbers are. Okay, so I'm going to do the East store first. So remember, you've got to take each number in the data set, and then you've got to subtract it from the mean. That's your first step. Basically to figure out how far away is that number from the mean. So we're going to do the number, and I'm just going to use our little hashtag to do that. So the number minus the mean, okay? Or if I really want to be correct and mathematical here, I would do my symbol for mean. So I'm going to take each number in the data set, and I'm going to subtract the mean to find the difference, first of all. So I'll construct myself a little table here. So my first number in my data set is 16. So 16 minus 37, because again, the mean is 37. And I'm going to put that difference out here to the side. It's negative 21. Then I'm going to go to this number next. 61 minus 37 is 24. Then I'll go to the next one. 22 minus 37 is negative 15. You get where I'm going with this. So I'm going to go ahead and pause. I'm going to do all that subtraction. I think it'd be a great idea if you went ahead and did that for yourself as well. And I'll be right back with you. So I get this process can be extremely tedious and frustrating because there are so many numbers in here. So I just want to point out really quickly before I go on. The first thing I did is that I went ahead and wrote out every subtraction problem, as you can see, and I double checked myself and I made sure, I went through here and I actually counted and made sure that I had 25 subtraction problems, because man, it sure is common to go through and think you got them all, and then you accidentally overlooked one. So now that I've written out all the problems, I'm going to go through and I'm going to do all of that subtraction. I suggest you do the same and then check yourself with me in a moment. Alrighty, so I have just gone through and I've done all of this subtraction, and the best advice that I can give you, because I know this is doing a lot, so the best advice I can give you is please take your time and double check yourself. I went back and I reworked every problem and actually found a couple of mistakes that I made the first time. So it happens to all of us. So please, please, please make sure that you're taking your time. This is not a problem to rush through. So we still haven't found the standard deviation yet. We've done the first step where we found the difference between each number and the mean. So now that we found each of those differences, remember the next thing we have to do is we have to take those numbers and we have to square them. So in other words, I'm going to zoom in here. So I'm going to do negative 21 times negative 21. I'm going to square it, multiply it by itself, and get 441. I'm going to do 24 times 24 to square that number, and so on and so forth. I'm going to do that for each of these. So 15 times 15 gives me the next number in the column. So I'm going to do that for each of these differences. I'm now going to go through and I'm going to square them. I suggest you go ahead and try that on your own too. Pause the video, try to do that squaring yourself, and then come back and check yourself with me. So now I've gone through and I have taken all of those differences and I squared them to get all the values in blue. So, and again, guys, I know all I can say is take your time, but I have double checked myself. I know for sure that my totals are correct, so you can, or that my answers here in blue are correct. So the next step is to take all of those numbers, so we took all the differences, then we squared them. So now we need to add all of those squares together. So I've got to go through and add all these numbers in blue, all of them together, all 25 of them. And if I do that correctly, I've already gone and double checked myself, I should have gotten a sum of 4,830. So again, after adding all those numbers in blue, I should have gotten 4,830. The next step, of course, is after I've added them together, I don't divide by 25. Okay, this is where people go wrong a lot when they're doing standard deviation. You're not actually dividing by 25 like you do with the mean. Remember that you're dividing by the how many numbers you have minus 1. So you're not dividing by n, you're dividing by n minus 1. So that means I'm taking that 4,830 and I'm dividing it by 24, not dividing it by 25. So if I do that, I end up with 201.25. And then my very last step is to take that 201.25 and take the square root. My square root symbols are really bad, by the way, guys, sorry. So take the square root, which you can do on any calculator. So finally, I get like 14.1862, like a very long decimal, which I'm just going to round. That's why I'm doing the little squiggly equal to sign, because that means approximately, because again, I am estimating. So the standard deviation is approximately 14.19. So the standard deviation for the East store is 14.19. Approximately, at least. So now we got to do all that again for the West store, right? So I am going to give you a minute to go ahead and do that on your own. I would love it if you would come back in just a few minutes. Store, we got a standard deviation of 14.19. So the standard deviation for the East store, we suspected it was bigger because the histogram was wider, and it turns out that we were in fact correct. The histogram for the East, and we just proved it numerically because the standard deviation for the East store is 14. So as you can see, my first step for the West store, I took all of those scores and set up subtraction problems. Then I went back and I double checked myself and make sure I wrote all those subtraction problems out correctly. So step 1, got them all written out and double checked myself. Okay, now for the next step, I went through and I subtracted, found all those differences. So now they're in green. And most importantly, yes, you guessed it, I double checked myself. Now for my next step, I am going to square all those numbers in green. In other words, multiply them by themselves. Okay, so now I've squared them all, and you guessed it, I've double checked myself. So now I've got all the blue numbers. Next step, of course, I need to find the sum of all of those blue numbers. So then I took the sum of all those blue numbers, double checked myself, and I got a sum of 1,406. So then I took that 1,406 and I did not divide it by 25. Remember, you've got to divide it by one less. So I divided it by 24, and I got, I'm going to round it because I got approximately 58. I'm going to round it to 0.58. And then I took the square root of 58.58, and I got approximately 7.65. So the standard deviation for the West store is 7.65. So for the West store, we got a standard deviation of 7.65. Whereas for the West store, it was only 7.65. So we should have picked the multiple choice answer that says the standard deviation of the East store is greater than that of the West store. So our answer for part D was verified. Okay, and so now I just did that same process to construct a frequency diagram for the West store, and just wanted to kind of highlight, I had to put a 0 here next to the interval 15 through 19, because in the West store there are no numbers that fall within the interval of 15 to 19. Had to do the same thing for these 3 intervals, because there wasn't a number at the West store that was bigger. Let's see, the biggest one, it looks like, is what, 51? So that means these last 3 intervals, we didn't have any, but those intervals are still in the frequency diagram, so we need to put zeros in their place. The other thing I just wanted to point out as an example, so remember where this green, the 8 came from. It's because there were 8 numbers in the West store that fell within the interval 40 to 44, and I've highlighted those in green for you too. So I followed that same process to fill in the frequency diagrams for both of the stores. So I've just completed part. Here's my frequency diagram for the West store. So I'm exactly the same to match up the histogram that goes with the West store. So, you know, the big thing you're going to notice here, right, is that after you get to this bar right here, which is where 54, after 54 is cut off, you don't have anything, do you? This is all empty space. There's no bars, and that perfectly matches up with the fact that you have frequencies of 0 for those particular bars. But we'll look at one more anyway. Let's look at 35 to 39. So if I zoom in on that bar, again, sorry about the lines, guys. So the 30 to 39, if you look over here to the side, it goes up to 6, which does match the frequency of 6. So that is how you figure out which histogram matches the frequency table. So we've gotten part B taken care of. So I'm going to store. Again, I'm going to zoom in. And your curve is roughly a little something like this. So the middle is roughly about here. And again, the middle appears to be surrounding this 40 to 44, or appears to be centered around roughly. And again, this is a rough estimate. Like I said, we're just estimating. The middle there, or the center, is 40 to 44. So that means you should select the multiple choice answer that says that the means appear to be about the same, because both histograms appear to be centered at around the same point. So, whereas this one is only spread out between about 20 and, 50, we'll just say 55. That's a decent estimate. So it's very clear if you're looking, one is taller and it is less wide. So that means that, check your answer with me. So now part B of this question asks you to construct a histogram for each of those stores. Now part C for this question then asks you to use those histograms to determine which store appears to have a greater mean, or do they appear to be about the same? So then part D asks you to use the histograms again, but this time it's asking you to determine which one appears to have a greater standard deviation. Remember that standard deviation is a measure of spread. So how far spread out are those numbers? So in other words, we're going to look for the histogram that appears to be more spread out, or the one that appears to be wider.